Hi, today we are going to talk about the binary trees traversal. So, the goal of this thing is to visit all the nodes in the binary tree in a certain order. We have three ways to visit the trees. The first way is called InOrder traversal. In this InOrder traversal, we visit first the left part of the tree, and then the root, and then the right part of the tree. So, and the same for the left part. So to visit the left part, first we visit the left part, and then the root, and then the right part. For this part, first we visit the left node, and then the root, and then the right node. So if we want to see how the order will be in the InOrder, let's try. We start from the root. So first we will visit the left part, but the left part is a root for this subtree. So again we will visit the left part, but the left part is again a root. So we'll visit the left part. So first we will visit the 4 because the 4 has no children nodes. And then after we visit the 4, because it's in order, we will visit the previous root, which is 10. After the 10, we visit the right part. So we are done with this part of this root. So after we finish with the left part, we visit the 15. And after the 15, we go to the right part. But before we visit 22, we have to visit 18, and then 22, and then 24, because it's in order. After we finish all this left part, we visit the 25. And after the 25, we go to the right part. But again, in the right part, we have to visit the left part first. But 35, before 35, we have to visit the left child, 31, and then 35, and then 45, and then we go to 50, and in the same way, we visit first 66, 70, and 90. So this order is called InOrder because we visit the root in the middle. So there is another way to visit the nodes in the binary trees is called PreOrder. So in the PreOrder, we first visit the root, and then we visit the left part and then the right part. So if we want to do the traversal here, first we visit the root, which is 25. And then we go to the left part. In the left part, again, first we visit the root, which is 15, and then we go to the left part. Left part, first we visit the 10, which is the root, and then we go to the left part, and when we visit the 4. After we are done with the 4, we go to the other child, which is 12. So now we are done with this part, we go to this part, but again, for this part, first we have to visit the 22 and then the children. So we visit the root before the children. After we are done with this part, we go to this part. First thing to do is to visit the root and then go to the left part. Left part, again, we visit the root and then the children, left child and then the right child. In the right part, first we visit the root and then left child and right child. So this is the PreOrder traversal. So the PostOrder traversal, we visit the 2 bars before we visit the root. So the last node to be visited is the root. So to do the traversal, we come here, we don't visit the root, we visit the left part. Again, here is the root, we visit the left part. Here is the left part. We visit first the 2 children before the root. So 4 and 12 and then 10. After we visit the 10, we don't visit the root. Still, we go to the right part. We visit the 2 children before the root. After we are done with the 2 bars, then we can visit the root. We finish all this left part, so we go to the right part. In the right part, again, we visit the left part first. In the left part, we visit the children before the root. And then we go to the right one. We visit the children before the root. And then we are done with the two parts. So we visit the root. And then we are done with the two large parts. So the last node to be visited is the root. So let's do the InOrder traversal. So we can easily do that using recursion. So we have a method called InOrder that takes nodes. If the node is null, we just return. We don't need to print anything. The root node is empty. Else, we do InOrder for the left part, and then we print the data of the root, and then we do InOrder for the right part. This is because it's in order. So, and then we have helping methods. It's called InOrder that take nothing but just do the InOrder for the root of the tree. Let's implement this method. So let's go to the NetBeans. So remember last time we have a class node. We did it together, and then we have this main class. We have also binary tree class. In the binary tree we have root, size, and height. And today we want to add new method. It's called InOrder. So this method is void, doesn't need to return anything. It just print, traverse the order in a certain order, traverse the tree in certain order. So it's very easy to implement the InOrder. If the node equals to null, then we just return. We don't do anything. We don't print. Else, if it's not null, we have to do three things. First thing is that we do InOrder for the left part, n.left. And then we print. I use print, not print line, just to make it in the same line. We print n.data. And then we make InOrder for the right part, n.right. So that's the InOrder method. So we can have a helping method, public void InOrder, that takes nothing. And here we just call the InOrder for the root. So if you call this method from outside, you don't need to give the root. So it will take the root as input for the other method. So now let's go to the main method. In the main method, last time we constructed a tree. So the tree has a root Ahmad, and then a left node Khalid, and then a right node Samir. Khalid has Hani and Salim, and Samir has a son as Muhammad. So let's do the InOrder. So the InOrder, we will start with Hani, and then the father, which is Khalid, and then the other child, which is Salim, and then we go to the root, which is Ahmad, and then we go to the right part of the tree, Muhammad, Samir. So this is the InOrder traversal. Now, as exercise, we need first to implement the three traversal methods. InOrder, we already implemented it, and the PreOrder and PostOrder. It will be similar to InOrder, but just we need to fix the order when we will visit the root. And then we need to write a recursive methods that sum all the integer values stored in the node, in the binary tree. So imagine we have binary tree and the data is not names, it's not string, it's just numbers. We need to write a recursive method that sums all the numbers of the tree. So again, we have to do traversal to sum all the nodes. Okay, and the last part, we have some order, InOrder sequence and PreOrder sequence, as we see, and we need to construct the original tree. So if we construct a tree and we did InOrder, this is the sequence. If we do PreOrder, this is the sequence. Can we construct the tree? That's all for this lecture, and we will meet in the next lecture.